Hello, in this video we will see some useful signal operations. Okay, so basically there are three types of operations which can be performed on the independent variable t. Okay, so the first one is time shifting. Okay, then we will see time scaling, and the third one is time reversal. Okay, so let us see. Let us first see what is time shifting. So consider following signal x of t. Okay, so this is the signal x of t, and then I'm plotting one more signal here, which is phi of t, and then one more signal. Okay, so this signal phi of t is this one. Okay, and the third signal is from this time instant. Okay, okay, and this time difference is of t. This is of capital T. This duration is capital T, and this is also capital T. Okay, so now you can see that whatever is happening in this signal for any time instant t is happening in this signal at after the t seconds, means at t plus capital T. So I can write this, means phi of t plus capital T is equal to x of t, means whatever is happening in x at t time instant, same thing is happening in phi at the time t plus t. Okay, so we can say that this is a delayed signal. Okay, and from here I can write that phi of t is equal to x of t minus capital T. This is t minus capital T, means if you can subtract minus t from here and minus t from here, we'll get this thing. Okay, so this phi of t is equal to x of t minus t. Okay, and we call this as a delayed version of x of t. So this operation is basically time shifting. Okay, so this is time shifted version. Now here, if in phi t equal to x of t minus t, so here if t is positive, then it will be a time delay. Okay, and similarly if t is less than 0, then this will be a time advance. Okay, so this signal is basically, we can write phi t equal to x of t plus capital T. Okay, so this is the advanced version of this x of t, because whatever is happening at time t will happen in this signal before t second. Okay, so this is the advanced version of this x of t. Therefore we can write that the signal phi t equal to x of t minus t naught. This is the time shifting operation, and we have said that if t greater than 0, then the signal will be shifted right side, or it will get delayed. Okay, and if t is less than 0, then the signal will be advanced in time by t seconds. Okay, here you can say delayed by t seconds. Okay, or left shift, you can say left shift, time advance is left shift. Okay, so now let us solve an example. So given an exponential signal, so we are given an exponential signal x of t equal to the power minus 2t as shown in below figure. Okay, so the given signal is this, to the power minus 2t, and this is 0 before t equal to 0, and it is to the power minus 2t, varying as e to the power minus 2t after t equal to 0. So this is our x of t. Now we are asked to first sketch and write the mathematical expression if x of t is delayed by 1 second. And in B part, repeat the problem given in part A if x of t is advanced by 1 second. Okay, so you have to plot, sketch and write the mathematical expression of this delayed and advanced version of x of t. Now let me copy this signal to the next page. Okay, so this is the given signal, and its expression is, we can write this as x of t equal to e to the power minus 2t if t is greater than equal to 0, and it is 0 if t is less than 0. Okay, because it is 0 here. Okay, so now let us define a delayed signal. Let me call the delayed signal as xd of t, which we can write as x of t minus 1. Okay, so as we have seen earlier that this t minus 1, so by this the x will be get delayed by 1 second. Okay, so we are calling this new signal as xdt. Now what will be xt minus 1? We can write from here, just replace t by t minus 1. Okay, so we'll get as e to the power minus 2 of t minus 1, and here t minus 1 should be greater than equal to 0, or it is t greater than equal to 1. Okay, and here So it will be 0 when t minus 1 is less than 0 or t is less than 1. So this is the mathematical expression, and now we have to sketch it. So this is t, this is x d of t, okay, which is equal to x of t minus 1. Now you see from here that it is 0 when t is less than 0. So this function, so this is t equal to 1, and before this the signal is 0, okay, and at t equal to 1 it is varying ways as this expression here, okay. So this is to the power minus 2 t minus 1, okay. So this is the plot, and the value of this thing will be equal to 1 at t equal to 1, okay. So this is the first part, okay. Let us define the new signal as XAT, okay, which is the advanced signal. So this will be equal to x of t plus 1, okay. So this is the new signal, and to write its mathematical expression we have to replace t by t plus 1, okay. So from this expression we have to replace, in this expression we have to replace t by t plus 1, okay. So this will be to the power minus 2 t plus 1 when t plus 1 is greater than equal to 0 or t is greater than equal to minus 1, and it will be 0 when t plus 1 is less than 0 or t is less than minus 1, okay. So we can plot it. So before t less than minus 1 means from here this is t equal to minus 1. So before this the signal is 0, and at t equal to minus 1 this is 1, and this will vary with to the power minus 2 t plus 1, okay. So this is the equation of this signal. Okay, so what we have seen in this video is that what is time shifting operation and how to perform the time shifting on the given signal, and we have also seen one example, okay. So in the next lecture what we are going to see is what is time scaling, okay. We'll see what is time scaling and what is time reversal operation, okay. So see you next time. Thank you.